Okay, I do apologize, ladies and gentlemen. I left my iPad at work. So let's just go ahead and go over this quiz. Hopefully, this will shed some light on things. We talked about the power plant today and releasing water, and we're going to determine whether or not it's having an effect on the distance that the fish are around the power plant. So, first of all, you had to enter your data into the calculator. Well, if you notice, there's my data in the calculator. And remember, in order to find the equation of the line, you simply hit calc, regression, x, a plus bx, and there's your a and your b. Okay, now next thing you have to do is you have to hit copy, go ahead and hit enter, and then hit enter again. Okay, what we can do is we can see if that, let's go ahead and graph it. Graph, yep, there it is. Another way we can do it is calculate x, a plus bx, copy, notice it's already in there from previous, enter, and then draw. Now remember, you can't do your shift trace here. You have to go to menu number 5, and then you have to select that. You have to draw, and then that's where you can do your shift trace. And of course, like we did when x was 29, we could figure out what the value of y was. So before I get to there, let's go back to here. Now it says, what is the slope of the line? Remember, this is another way I did it. So this is write the equation of the line and define any variables. Well, I put temperature as my y hat equals negative 74.7 plus 5.79 x, which is my distance. Okay, so as long as I'm just basically looking that you understand what the variables represent. All right, let's go ahead and go to here. So what is the slope? Slope is 5.79 meters over 1 degree Celsius. So for every 1 degree Celsius, the distance to the nearest fish would increase by 5.79 meters. Disregard that misspelling. Increase by 5.79 meters. All right, then it says, use the regression line to predict the measured distance when x is 29. Well, if you do it mathematically, you plug in 29 and you'll find that it's 93.229. Or, remember, you can go to this way and do the same thing. Now, granted, this one gave me the 93.22. Let me go ahead and focus. There we go. Okay. Now, you could do it old-fashioned mathematically and just plug that in and solve for the equation. All right, now the next thing we're going to do is we're going to talk about the residual. Notice this is when x is 29 here, y is 76. So in order to find the residual, we're going to take our observed y, which was 76, and we're going to subtract the residual, or sorry, the predicted y, which we got in the problem before. So make sure you're understanding what I'm asking for. So you're going to have this exact same type of problem, where you're going to have to subtract the observed minus the residual, or minus the predicted. You get a residual of negative 17.229. Now, when you graph it, notice that my observed point is below the line of best fit. Okay? So that's why the residual is negative. Now, does the linear model overpredict, underpredict the measured distance? Well, since it's a prediction line, and according to that point only, since the predicted line is above the actual data point at x equals 29, then at that point the line is going to overpredict the distance. Okay, let's go to the back side. All right, on this one, is it reasonable to use your model to predict the measured distance from the outflow pipe to the nearest fish if the temperature of the discharge water is 45 degrees? Well, if you notice, our data, the domain of our data falls within 16 to 38 degrees. All right, so if I go back to menu, if I go to number 2, let's go back to menu, let's go back to number 2. Okay, notice 16 is my lowest, 38 is my highest. So my domain is between those two numbers. If I'm asking them to go to 45, notice 143 meters. Well, a football field is 100 yards. So if you think about meters versus yards and how close they are to each other, well, if you plug in 45 here, you're going to get about 185 meters, and that's what I did. I went and predicted 45 degrees. Uh, so basically what I'm saying is to go much further out from your listed domain would not be reasonable in this case, because we are looking for the area that's around the water the power plant. So, and I think that the 45 degrees would give a distance of 185 meters. That's almost 2 football fields. So, which is not around the power plant, so to speak. So, no, it would not be reasonable. Now, when you look at a residual plot, there's no pattern. Therefore, the straight line LSRL does a good job of predicting and describing the data, and that's what we want. Had this had any pattern, then the graph would not be linear. It would actually be either quadratic or exponential or cubic or something like that. Now, one of the things I didn't go over too well is how to create a residual plot. Well, remember, in order to get your residuals, we want to put them in list 3. So what I'm going to do is I'm going to hit Shift Menu, which is the setup. Notice there's a resid list. I'm going to put my residual list in list number 3. And then I'm going to hit Enter. Now, once I've done that, I'm going to exit out of there. And now I'm going to go through the process of calculating my line of best fit. And once you do that, those numbers will show up. So calculate regression x a plus bx. Okay, I'm just going to go ahead and hit exit, and voila, there they are. Now notice, when x is 19, your residual is going to be about 4.6, close to 5. And when your residual is 16, it's going to be almost -8. And if you look at the graph, that's what I did here. I listed my L1 and my L3s. And then I plotted them. So look, at 19, your L3 is going to be 4.67. Now, let me explain to you what you draw. Notice, here's my x-axis. My y-axis happens to be the range that my residuals fall within. My highest residual is 17.9. My lowest residual is -17. That's why I went from 20 to -20. And I just used the points 10 and -10, and of course 0 is in the middle. And that tells me the vertical distance. So look, when x is 16, I went down to -7.9. Notice it's just above the -10. And then on 19, it's at almost to 5. So at 19, 19 would be just before 20. 5 would be just above the line. And you go through the entire set of residuals, x and residuals, in order to graph this. And that's all you do. Remember, go ahead and put a title. This is your residuals. So look, if you notice, my y-axis is my residuals. And then my temperature are my x values. That's your L1. All right, the last thing we didn't go over is this question here. Let's go ahead and read it. A study of many countries find a strong positive correlation between the life expectancy in a country and the percentage of households in the country with telephones. Sort of like the TV problem that we have. Does this mean we should simply donate more telephones to the countries with fewer of them to increase the life expectancy there? Remember, this is a nonsense correlation. Okay? It's a nonsense correlation. In fact, you could actually draw a diagram where you would have phones, we're going to put that P, and life expectancy, we're going to put L for here. Well, we know, just like with the televisions, wealth allows us to buy phones. Wealth also helps us increase our life expectancy. So basically, this is what we call a common response. There's a relationship here somehow, but what causes it is this lurking variable of wealth, nation's wealth. It causes us to be able to buy more phones, and it causes us to be able to eat healthy, have better medical care, and so forth. So this is our lurking variable. Even though we see a relationship here, this does not cause this. Okay, again, this is a common response. And that, ladies and gentlemen, is your review over this problem. Good luck tomorrow.